Hey friends, welcome to the YouTube channel all about electronics. So in this question, we have been given this two-port network and we have been given the Z parameters for the given network. So here, we have been asked to find the value of RL such that the maximum power gets delivered to it. Now here, we have been given the Z parameters for the given network. So first of all, let us write down the value of V1 and V2 in terms of the Z parameters. So we know that the voltage V1 can be given as Z11 times I1 plus Z12 times I2. Similarly, the voltage V2 can be given as Z21 times I1 plus Z22 times I2. So from this we can say that voltage V1 is equal to 100 times I1 minus 500 times I2. Similarly, the voltage V2 can be given as 1000 times I1 plus 10 to the power 4 times I2. So these are the expression of voltage V1 and V2 in terms of the I1 and I2. Now here we have been asked to find the value of RL such that the maximum power gets delivered to it. So in other words, we need to find the Thevenin's equivalent resistance which is seen through this port 2. Or in other words, we need to find the value of voltage V2 divided by I2 when all the independent sources are 0. So this will give us the Thevenin's equivalent resistance, and whenever the value of the load resistor is equal to the Thevenin's equivalent resistance, at that time the maximum power will get transferred to it. So first of all, let us find the Thevenin's equivalent resistance considering all the independent sources in the circuit as 0. Now if you notice over here, if we apply the KCL at this node, then we can write 1 ampere is equal to current I plus I1. Or in other words, we can say that current I is equal to 1 minus I1. Now here the voltage V1 is equal to I times 0.5 kilo ohm. Or in other words, 500 times 1 minus I1. So this is the expression of V1 in terms of the I1. Now here, to find the Thevenin's equivalent resistance, we will assume that all the independent sources in the circuits are 0. That means we will assume that this 1 ampere current source will act as an open circuit. So in this condition, this voltage V1 can be given as 500 times minus I1. So considering this, now let us find the ratio of V2 and I2. Now if we put the value of this V1 in this first expression, then we can write minus 500 times I1 is equal to 100 times I1 minus 500 times I2. Or we can say that minus 600 times I1 is equal to minus 500 times I2. That means I1 is equal to 5 by 6 times I2. So now let us put the value of current I1 in the second expression. That means voltage V2 is equal to 1000 times 5 by 6 times I2 plus 10,000 times I2. That is equal to 5000 divided by 6 plus 10,000 times I2. Or in other words, V2 divided by I2 is equal to 10.833 kilo ohm. So this is nothing but the Thevenin's equivalent resistance. So in other words, we can say that for the given circuit, the Thevenin's equivalent resistance is equal to 10.83 kilo ohm. That means for the maximum power transfer, the value of RL should be equal to RTH, or in other words, it should be equal to 10.83 kilo ohm.